So, hi everyone. Um, in this episode, session, whatever it is, I'm going to explore some of the object-oriented capabilities of Rust, of the Rust programming language, though Rust for many is not really an object-oriented programming language. There are some concepts that are definitely not typical object-oriented programming. These concepts are, for example, lifetime or ownership. They do not exist in the realm of object-oriented programming. There are the things that are, probably the closest version of OOP for Rust, which is the use of generics um, that resemble or well, allow you to have some sort of polymorphism. But other than that, well, there is also the trait concept, so you can have structs and enums, and which is the data part of your object, and then you can implement a trait in Rust, which is the code part of your class. And so that's probably where you find some analogies with OOP. But other than that, I don't recall any other concept that is typical Rust. Now, I'm not a fan of object-oriented programming, but sometimes it helps, and organizing your code in a particular way that is easier to maintain. But there are many other things that, when you want to use idiomatic Rust, I don't think you should choose OOP. You probably would like to stay as much idiomatic to Rust as possible. But anyway, in this session, I want to write a very small program that shows some concepts around OOP for Rust. And so I decided to, I got inspired by the Rust programming language, which is a very nice book. I will report in the comments, and yeah. So the application, the application that we can use for, explaining some concepts is the typical. It's very similar to what happens, for example, on email server. So you have an email that is an object that has, a subject, a body, and a sender, a recipient, or a list of recipients. And so what happens is that you send this message, you write the message, so you somehow edit the body of the email. And then on the other side, the recipient will ask the server to, get access to the email before reading the body. Right? So that's the mechanism that you want to implement. And so if I don't ask the server to send me, to download the email, I cannot actually read the content. And so I cannot read the body of the email, right? So this means that the email will be in a status that is not, in multiple states. And when the email is in a draft state, of course, I cannot read the body. But when I am in a, I don't know, published status or, yeah, I mean, I would call it published, but okay, we'll see how I get inspired as I write code. But you know what I mean. It's like an email can be in a draft status or in a published status for which the recipient can in fact read the body of the email. This is not how emails work, especially IMAP servers. They don't work like this. I'm just making it up for for the sake of explanation. So let's get started. I guess you guys can see this. Yes. So I'm on Visual Studio Code with RLS installed. Works pretty decently. So okay, let's see if you have a function main. Let's see if all is in place. What am I doing? Print line. Hello. Let's see if that's cargo build. Yep, all works. Okay, we can start. So I will start by, in fact, coding in a way that is known as top-down or top-bottom programming. That is, you start from the API, so you start from how the end user is going to use your code or your library or whatever it is. And so what we would like to do is like creating an email that is, for example, a new empty email in a draft status. We're going to define these things. And then I want to write the email, so I will have to call some sort of write method. Hey, this is a message for you. Okay. And then what happens is that if I try to print email dot, let's say, get body, all right, this thing should be an empty string because the email is in a draft state. And so what I want to do is that this get body is equal to an empty string and then what else is that if I, as a recipient of the email, I ask the server, okay, send me the email, so I want to read that email, or I'm opening that email, I would call eventually email.request email, and now what happens is that this assert is different because I take the body and that stuff should be, well, I want this to be equal to the initial message, right? So just copy and paste here. So this is what I want to implement. Now, of course, this will not compile because we haven't defined anything. So this is just the main. So now we have to implement the things that we need to implement, right? So the very first thing we want to do is defining the struct of our that will contain our email. So let's define it as a public struct. It's an email. This is contains, of course, a status and eventually a body. Now it can contain many other things like, you know, the sender, the recipient, could be probably a vector of strings, etc. So you can complicate this as much as you want, but let's just keep it simple. So the status is it's some sort of status object that we're gonna define, and the body is, of course, a string. All right. Now the status is an empty struct. Actually, no, I want to do it better. The status can be a trait. That is currently empty. So the thing is that the status is, it can be multiple things. So an email can be in different states. It can be a draft. It can be an opened, a requested email, for which the body, you know, can be read or not, depending on in which state we are. So if you look at main, here we want the email to be in a state that is draft, right? And so that's why once we are in an email that is in a draft status, when we call the get body, we get an empty string because even though we initialize the email with a a non-empty string, we're gonna get an empty string because of the status, the internal status of this email is draft. But when we call request email, we are in fact changing the status of that email, and then when we call the get body, we get the message. So that's the functionality that we want to implement. And this means that status cannot be a struct. It has to be a trait, because that trait will be implemented for different statuses. All right, so what do we do with the status? Well, the status is a trait that implements several methods, of which we provide only the signature. Okay, and then we have the the particular status, which is, for example, a draft. And then what we want to do is implement a status for draft. Okay, so what is the status? In the status, I can be implementing methods like view. So the view method in fact receives a self allocated on the heap and returns a status. Now, since the status is not known, okay, this is a signature. Right, so here the compiler is already telling us something nasty is gonna happen, so this will not compile clearly. Okay, so since the status is a trait, it means that when you return a status, you don't know what it will be. And so that's not an actual object or an actual type. It's a trait. So what you want to do is alerting the compiler that what you want to return here is a pointer on the heap. So it's definitely a box. And then you have to use the dyn keyword to indicate that we are going to return something that implements a status, but we don't know what, because we don't know where do you call this, right? So you can be calling that on an email with in a draft status or in a opened status. You don't know. Definitely not at compile time. Another thing that we want to implement is the request email function. So let's call it request email, because in the API we had defined that. And so this is very similar. So it will have a self box self and returns again box status. Okay, and finally we the get body. So the get body is a method that receives. I will keep it for later. Okay, this can be a bit more complicated. So let's go implement now the email. Oh, hang on, here there is a problem. So this again, the status, we don't know what status it will be. And so you probably got it. This has to be a box dyn status. And since it can be, well, we can even put this behind an option. Okay. So at this point we implement a trait for email. So okay, and here we have some functions like, okay, the new, we have to implement this stuff. So it's a public function, new. This returns an email struct. So as you can see already, we have some object-oriented ideas here, like the public method. By default in Rust, everything is private. And so even here, status and body are private by default. So they can be accessed by a method within the trait only. So this prevents you from changing or accessing directly the fields of a struct or an enum. And so this returns an email as a struct, so we have to initialize it with status that is a sum box new, and we define the new type. The real status is draft. We have to define draft later. And the other thing is body. This is going to be a string new, an empty string. Okay, the other method that we want to implement is the write. So we also have a public function write. Now this write will change the email struct, so it has to have a reference, a mutable reference to self, and of course the text of the email. Let's call it body text. That is, we can use a stir, so that's a reference to slice. And what this does is basically setting body, and we push string body text. Yeah, body text is a reference to slice, push string wants a reference to slice, and we add it to body. Okay. All right, so another thing that we want to do is the method request email. This is the function that when you, well, we need to implement the get body, but that we keep it later. Request email is the function that changes the state of the email you are calling the function on. Okay, so the idea is like, if you want to print the body of the email that is in a draft status, you're gonna get an empty string. But if you request the email first, that request email will change the status of that email, and then when you call get body, you have access to that data, to that string, right? So let's implement the request email. So request email will change the status, so it's again mutable self once as an argument. And now you are going to take the status and whatever status you take, okay, whatever status you take, you're gonna call the request email on the status. So you're gonna do s dot request email on the status. You put this into a sum and you write the status. Okay. So request email, as we can see, takes the status of the email and calls the request email of that status, which means that in our trait status we have to implement this request email. Make sense? Of course it does. Now we have a function getBody. The getBody can access the email without mutable because it just returns a string slice. Oh, Python. Curly brackets in Rust for a block statement. All right, so what do we do with getBody? Well, getBody, this is a bit tricky because getBody is gonna, it's gonna return the body of the struct, right? But we don't want to do that, right away, because we have decided to return the body only if we are in a particular state. So if we are in a particular state means that we have to use the status of that email and call the getBody on that state. And then the state will have the logic that says, okay, I am draft, I will give you empty string. Oh, I am published email, and I will give it a body. So we move the problem to the state. And that's typical object-oriented, right? It's you implement something and then you call an object that implements that something that calls another object and implements the same shit. And it goes like that until you materialize what you are asking, right? So, okay, we have to take the status, so well, let's do that. Substatus, easy. Now the status, we have to take the status as a reference. We'll unwrap the state, and then on this object we call the getBody. All right. There is still an error because we haven't implemented getBody for status. Yes, because we left it. So now the getBody is a method that is implemented in the status trait, and by default it will return an empty body. So it accesses the self as a reference. It receives an email object. Well, let's call it struct. It's not an object. And returns a reference to slice. Okay. So this stuff will return empty. Okay. All right. Oh, this has to be a reference. Nice. Okay. Now we can implement a draft struct, a new type. Okay. So in this type, the method getBody. So we have to implement the three methods: view, request email, and getBody for all the types or for all the status that we're gonna implement. So in this case, we have draft. We can create a new one like I don't know, like opened, and of course we implement status for opened. Okay. Now there are some, the compiler is already asking us, dude, you have to implement, if you are implementing status, well then status has these three signatures that you're not implementing here. So please do. And same here. So if you look at what this is, the RLS is telling us, not all trait items implemented, missing, view, request, email. Okay, it's only view and request email because in fact getBody has been implemented. So by default getBody is this, it returns the empty string. While view and request email, they only have the signature, they have no implementation. This is the equivalent of the ABC in Python, or I hate mentioning Python for these things. I mean, this is serious programming. Python is not serious. Well, abstract classes, in fact, that's what it is. So, well, let's implement view. So view has access to self, which is a box of self, so it's from the heap, and returns the same box box line status. Okay, what's the implementation here? Well, we have to return a box of something. So if you view you should return self. But if you request email, you return exactly the same. But this time we return a new thing on the heap. Well, if you request email, I would say it changes the status into opened. All right, empty. It's a new type. Now, as you can see, this makes sense because this function is saying, hey, I'm gonna return something that implements the status trait. So it's gonna be something that is a status, but I don't know what. I know now it's an open. So in this particular implementation of status for draft, when you call request email, you get an open. That's why you cannot return just status, right? And the other function, getBody is empty. So if you are in a draft status and you want getBody, We just reuse this default, so we don't implement this. We use what the status trait is telling us to do. All right. Now, I think it's oh well, we need opened. Well, again, if you want to view, we can copy this in open and request email. Request email. Well, this also returns, well, in this case, well, now, so in this case, we also return self, because we are in opened, and you say, once you're in opened, and you request email, you have already opened the email, so just return self. But if you call getBody that wants self and email and reference to email, this will return a reference to slice that is take email and you return the body. Okay, so lifetimes. Ooh, okay. So lifetime mismatch, this is a nasty one. This is something that took me a while to understand. So in Rust, here we are returning, so this is lifetime in action. It's a pain in the ass to understand, but basically it's saying you're returning something that can have a shorter lifetime than the function itself, which means that once you exit this function, you run out of scope. And if you go out of scope, then what you're returning here, is dropped, and you would be in front of a dangling pointer. Now, Rust is very good at avoiding these things at compile time. So there is new paradigm of programming that is a bit nasty but very effective, that basically tells you, hey, define me the lifetime and please tell me that what you're returning as a lifetime that is at least as long as the function itself. And all these things that I said with English can be written like this. So the lifetime of this is gonna be this. So we have the same lifetime of the return value. What is it saying? Item signature. Oh, okay. Of course, we changed the signature, so we have to go here and change the signature. Okay. Yeah. Okay, so basically, you see what I did? Here. I changed the signature of the status of the trait to be, to take into account the lifetime of the return value. And so when we implement, okay, for draft we didn't implement getBody because it will be like the default, but for open, the return value, the getBody will actually return something, and here we have to have lifetime in place. Okay, so now let me print something here. So if you try to print try to read body without consent. right? So here I try to read email.getBody. Oh, of course. Let me remove these asserts, otherwise we don't see anything. Okay, so I try to print email get body. So let's see first if it compiles. Okay, with a small warning that is, okay, dude, you're not using email in the get body function. Makes sense. So here we are only using it here, but in the signature here we are not using it. Yeah, okay, it's a warning. Eventually we can add this macro, I guess, here. No, I'm learning, guys, still. Whatever. It's okay, got it. Or you can do this, but then it will break the signature down there. Let's keep the warning for now. Let's see if everything works. So cargo run. So we create the email, we change the text, the body, we try to print. This should be empty. Then we request the email and we print again. So trying to read with consent, right? So let's see. You see? Trying to read body without consent, try to read body with consent. So it works. Probably the thing that, okay, I will see how I can fix that warning, but that's not the point. So this is, as you can see, there is a lot of object-oriented flavors in this Rusty code. I still don't like it, honestly. One thing that I really don't like is this replication. Like, there is code duplication in here and here. So this is something that it bothers me. Okay, here we are specializing the request email for this particular implementation. So that makes sense. Here we are overriding the get body, so we use some sort of overriding prediction, overriding capability. But there are other ways, of course, to implement this in a more Rusty way. I have to think about it, but this is it, and I hope you guys had fun. Talk to you next time.